Hi everyone, my name is Daniel Yu. I'm a sports scientist and strength coach in the NBA. Just wanted to make this video for you guys today on how to download R and R Studio, as well as some fundamentals of R, including how to read in a data file, how to look at it, and then making some cleaning on that data set. So we'll go ahead and get started. I'm going to go ahead and start by sharing my screen. So this website right here, cran.r-project.org, this is just where you would download the language R. So I have a Windows. I'll just go ahead and click on download R for Windows. If you have a Mac, click on the one for Mac. And then for here, it'll just tell you download the base option. So this is what you want if you're installing R for the first time. Click on that. And then I have the 64-bit Windows too, so I'll just go ahead and click on that. So that's going in my downloads. That'll get going. And then the other website you'll use is called posit.co. Posit is just what our studio has rebranded to, but it's just a coding environment that is friendly, makes R a lot more approachable. So highly recommend using that. Once you go to posit.co/downloads, you'll get this screen right here. And then you could go ahead and click download R Studio. That'll bring it to your desktop, and then you just pick the version that you want again. So Windows again for me, and I'll go ahead and click on that. So that'll get downloaded in the background. I already have it installed, so I'm going to go ahead and cancel that. And then let me go ahead and open up R. I'll share my screen again. Okay, great. So I'm in R Studio now, and what you can see is that there's four applications you have, or more so four windows. You have your top left, that's where you're going to do all your coding. Anytime you run a line, it'll go into your bottom left. Your environment is going to be where all your data sets are going to be stored. And then this bottom right is where you could pull files from your computer, or if you run any plots, it'll go there, packages that you have. And then also if you have any questions about functions, you could go to the help and search for them as well. All right, so now that we have that open, and it's reading from our R file. The first thing I want to show you guys is how to install packages. So I'll just go ahead and comment this out, install packages. And that's all hashtags do. Hashtags just allows you to write lines without running it as code. It just creates it as comments. So to install packages, all you have to do is type install.packages, parentheses, and then all packages need to be in quotations. I used to make this mistake all the time of not. So the first one we'll do is tidyverse. So tidyverse contains a ton of different packages, and it's really my go-to. So whenever I open R, I'm going to load that first thing. So we could go ahead and install that. Another one we'll install is install.packages and read Excel. This allows us to read in Excel files. And then to run these lines, I'm just clicking Control Enter. And the final one that I'll use is called Janitor. So this is the package that we will use to help clean up the data set and put it into a proper format. After this, we will load our packages. Let's see what's going on here. All right. And to load your packages, once package, so you don't need to put it in quotation marks anymore. That's just for the first time that you're installing it. So we'll go ahead and load it. And then you can see in the bottom left, every time you run a line, it'll load. We'll also load the read Excel. And then we will load janitor. All right. So the first thing we want to do is read in our data file. Let me type that out, read in our data file. And for today, our data set from this research package or this research paper talking about force plates. I'll link that in the comments for you guys to access, but that's also where you can download this data set as well. So it's a public data set. We'll call it force plate underscore DF. DF just stands for data frame, and we'll do a less than sign with a dash. And the function to read it is called read underscore XLSX file.choose. All this does is when I run this line, it'll bring up a clickable interface for me to select the Excel file. So I'll go ahead and run that line. Another way you could run it is just by going to this run button up top. I'll run it. It's popped up, and what I want is called this data set right here. That's just what it's called when you download it automatically from the website. Okay, and we have our first pop-up in this top right corner. And this top right corner, it just stores our data. So we could go ahead and click on this box to the far right of it, and then we can see that it'll pop up. So this is what the data set looks like. It gives us some quick information. It tells us there's 200 entries, so this means there's 200 rows and 11 total columns. And we could quickly scroll through it. We have one for subjects, one for sides, one for trials, jump distance, ground reaction force, peak ground reaction force, peak resultant force, etc., etc. Another way of looking at this data set is there's a function, it's called glimpse. I use this a lot, and the force plates underscore DF. So I'll go ahead and run that. And then all this will do is it'll tell us and provide a snapshot view of that data set. So once again, it tells us there's 200 rows, 11 columns, and these are the column names. And also tells you the type of column it is. So it tells us joining data sets. So in this instance, subject is a number, right? You would, and that data set is reading it in characters. Well, it's not going to join in this instance because your subject here is a character. So this is where you just have to convert the character column into a number in order for it to join. So that's why this function is especially useful, the glimpse data set or the glimpse function, so that you can see what type of character your columns are. All right, so now that we've read in our data set and we viewed it, we could go ahead and let's start we'll just call it cleaning. So cleaning is especially important because in sports science, you always want to store your data in a clean function so that later when you use it, it's easy to join different data sets. So what might that include? That might include cleaning your dates. So if your dates are in Eastern time for one data set, but it's in Western time for another data set, you want to put it all to the same time zone consistently so that it is getting stored as such. And then this way, when you're joining it, it's all nice and smooth. You also want to have unique IDs. So in this case, the ID is 1, 2, 2 underscore B, 3. That's okay. We could play with that, but things that you especially want to avoid is things like first name and last name, just because sometimes people will have the first name and last name, and then when you're joining data sets, it'll get confused and won't be able to join properly on that. You also want to avoid any empty cells, columns, or rows. So let's call this new data set force plate underscore clean, just because we'll pretend like this is something that we're cleaning. And then once again, we're doing that less than dash sign to assign it to it. And then our original data set was called first place underscore data frame. And then here we're going to use uh, something called a pipe. So that's that percent less than percent. And that's kind of just our grammar for joining different lines of code. So our next line is just going to be called clean underscore names. And this comes from that janitor package that we were talking about. All right, so we went ahead and we ran that. And then once again, we could go to this far right spot and view what that cleaning did. So here we go ahead and clicked on it again, and we can see now everything is lowercase. There's no spaces between the column titles anymore. Everything has an underscore between it, and that's part of the cleaning process as well, is in general you don't want to have stuff that um, is capitalized, because that's just an additional thing that you'll have to worry about if you have like a capitalized character, a lowercase character, capitalized character, a lowercase character. There should be no spaces and no special characters. So this is a great function that I really like from Janitor that just allows you to do those things really quickly. And then let's say we want to create some new columns. So from here, let's say we want to get body weight. Body weight is something that is important to us. So in order to create new columns, you use the function mutate, and this is what I would consider one of the most used functions in R. So mutate just allows you to create a new function, a new column. So we'll call this one body weight. And then same thing, I'm following that format of all lowercase with the space, with no spaces, so this underscore. So body weight equals, and then let me have a glimpse at our data set real quick. Force plate clean. We'll take peak vertical ground reaction force in newtons. So what I like to do in order to like avoid any typos, I like to just highlight it. I'll copy it, Control C. I'll paste it in, Control V. And I will divide that by the norm peak vertical ground reaction force, newtons per kilograms. So newtons over kilograms, and that will give us kilograms. And then we'll multiply that by 2.2, which will bring us to pounds. Let's go ahead and run that. And we can see we ran it because it showed on that bottom left. And then let's go ahead and view it. So now we see we have this new column. It's called body weight. And well, we don't see all of it. Let me pull it up on the through the view function. Here we go, body weight. So this person's subject one is 192.69 pounds. This person is 226 pounds, et cetera, et cetera. And if this is a data point that we want to collect consistently, this is a great script for it now for it to automate for us, right? So anytime we export this data file from, let's say they're using some type of force plate company and they exported it and it came in this file without the body weight. Once we have the script written, we just rerun it every single time. We don't have to type this out anymore because it helps automate our process and makes it very systematic. We'll be able to get body weight and we'll be able to store that consistently within whatever platform we use to store our data. All right, so we cleaned the names up, right? We changed the formatting. We learned how to create new columns, and then what we'll do next is remove any NAs. So let's go ahead and click drop NAs. And this is really easy. It just removes any any missing data. And we can see we went from 12 variables to 11 because it removed one of them. But we could also, like in that original, let's see what it removes first. Oh, actually, no, it didn't remove anything because there weren't any missing data because we still have our 200 rows and our uh, 12 columns. But that's just the function that you would use to remove any missing data. But let's say we only want to have keep the subjects that had three total trials. So what we could do is we could do a group by statement, and we will group it by the subject and the side. So we want to make sure they got three jumps per side. So we could see subject one, they had three jumps, right, on the left. And subject one also had three jumps on the right. Then we'll do, we could see that for two as well. We could see that for 2B. But instead of going through all 200 columns, let's do it at scale. So how we do that is we group it by the subject and we group it by the side. And then we'll create a new column like what we did above. So that's mutate. And then we'll call it total trials. And the function is just n parentheses. And that will count up the total number of rows based on whatever you group it by. So for subject, it'll group it by the subject and by the side. So we'll go ahead and run that. And then let's just view it. I'll type it out. View, force plate, square clean. And we can see on our far right now, we have the total trials. And as we said it earlier, for subjects one and two, we had that. What if we sort it? Okay, so we sorted by low to high here, and we see that there's this person only had two trials, or actually it's a couple people, because you can see the difference by their weights as well. And then if we scroll over here, yeah. So subject three only had two trials, so did 3B, 7, and 12. Let's just say for the sake of this workshop, you only want to have people that have a total of three trials, right? Let's say that's our standard procedure, and those are the only types of data that we want to store. What we could do is it's called filter, and this is how you remove data. We want filter total underscore trials is equal to three. So they have at least three trials, or we could go total trials is, well, yeah, let's just go with equal to three. So we went ahead and ran that, and then we could see in in our top right, we actually removed some rows because originally we only had 200 observations, right, or 200 rows, and now we have 192 because it removed those four people that only had two trials. So it removed eight of those rows. So that's how you would um, remove any trials that might be missing or just manipulate your data set in general. And then let's also rename some columns. So I'm not the biggest fan of, let's say, I'm gonna go ahead and run this again so I can look at it. Like ML underscore jump distance underscore M. That's not something that's very intuitive or I understand right away. So I copied this. I highlighted it, I copied it, and I want to rename this to just be called jump distance and we'll keep the unit as well, jump distance in meters, and that will equal what I copied here. So all this function is doing is it's renaming your columns. So let's say this is how that force plate platform exports their metrics every time. This is what it's called, but I don't want to store it as that. So every time I export it, I'll run this file so that it cleans up some of my data. I'm getting back body weight. I'm only keeping trials with 3, and I'm renaming the name so it's more clear. So I'll go ahead and run that. Let's go ahead and view force plate clean, and we can see now that metric is called jump underscore distance underscore M instead of M underscore L underscore distance underscore M. And then you could do that with all of them as well. You just go comma, enter, and then here we'll do a couple more. So instead of maybe peak M underscore L underscore GR ground reaction force underscore N, I'll just call it lateral or peak underscore lateral underscore ground reaction force in newtons equals that, and so on. And then finally, let's say I don't care about all of those metrics, right? I only want some specific metrics. So in order to do that, it's simple function is called select. And let's say I only want the subject, the side, trial, and body weight, and these 2 metrics that we made. So we'll just copy that, paste it, and then copy that and paste it. All right. So now we have a clean data set. In this instance, we have our subject with a unique identifier. We have the side they completed the force plate jump on. And we have the trial number, the weight, and then the metrics with their column names without any missing data. So that is excellent. And then let's say we also want to do some outlier detection work. So we want to clean up this data set even more, okay? And how we would do that, well, there's actually a couple ways of doing it, but in this case, we'll just use standard deviations as a way to detect outliers. So once again, we'll call it outlier detection less than dash. So this is the new data set that we're creating. The old data set that we're using is going to be force plate clean. I'll copy and paste that in. I'm using the pipe function. And to get the pipe, I'm just clicking Control Shift M as well to get that. And then what I want to do in order to do this at scale, instead of doing it for every single metric individually, I want to go pivot longer. So this puts the data set from a wide format into a long format. This is especially useful when you have a lot of metrics that you want to do this to. So pivot longer, columns equals C. And in this case, our columns are jump distance M, peak lateral ground reaction force. So I'll copy and paste that in, and you'll need quotation marks around them as well. Comma, enter. And so for all of those columns, we're going to put it into one column that we call metric. And then for all of their numbers or values, we'll put it into a column called value. So I went ahead and ran that. And this is what it looks like when you turn something from a wide format into a long format. So previously it looked like this, right? So these 4 aren't changing: your subject, your side, trial, body weight. Those aren't changing. The only thing changing are your metrics. So from jump distance, peak lateral ground reaction force, instead of having it side by side, I'm putting it into this one big thing. And this is going to really speed up my process, especially when you have more than 2 metrics, which we could have used earlier, but just for this example, we'll run with it. And what we'll do is we'll group it by the metric, okay? And what we can do is we'll create a new column. We'll call it 3 standard deviations, and that will be the mean. So we're taking the average of the value for both of those metrics individually, and we are going to add 3 standard deviations to it. So the value for standard deviation is SD. I'll put in value and then multiply it by 3. I'll go ahead and run that and show you guys. Okay, so we know for the jump distance, anything above 3 standard deviations is 2.5 meters. And for lateral peak ground reaction force, anything above 3 standard deviations is 1,090. And then what we can do next is we'll create a column, we'll call it outlier. And this is essentially like an if-else statement, but this is called case when in the dplyr package. So we'll go case when the value is greater than, and then in this case, we're calling it 3 standard deviations. We will call it outlier. And if the value, actually, that's all we need. If it's greater than 3 standard deviations, we'll call it an outlier. Otherwise, we will call it normal. It's within the normal data range. All right, so we'll go ahead and run that outlier detection. And now as reviewing it, we can see that everything is actually normal. There are no outliers within this instance of the 3 standard deviations that we set. Let me just change it so that we do get some metrics shown in there. So turn it into 2 standard deviations instead of 3. Copy and paste. We'll run that again. Outlier detection. And then now we can see these metrics are outside of that bandwidth. So we can see that and then we can see that the data set has decreased because we don't have any outliers anymore. So it's normal now. And then if we put it back in a wider format, it'll be less than our original for split clean. It says 377 because put it back normal format. So pivot wider names from, that's going to be from the metric column that we created, and values is going to be from the value column that we created. And that run, yep. Fire detection has NAs. I just have to, what we gotta do? To remove the original columns that we made. So that's going to be the out column and the 2 standard deviations column. And here we go. So now we have some, the data was removed for those data points that were considered errors. So that'll be here for 6C and here for 12B. So that's just one. Have other methods like interquartile range, as well as others. But here's just one of the methods. I'll go. But yeah, thank you all for tuning in today. Really appreciate your time. That's just a quick intro on downloading R and getting started. Hope you guys enjoyed it.